Hi guys, I'm Dawick, and today we're gonna learn about summer shapes, or you could say specifically the interior angle sum. This is a quite logical concept. I wouldn't say simple. It has logic and evidence backed up by it. First, let's start with the simple shape. We've got a rectangle over here. In a rectangle, we have 4 right angles. Now right angle is equal to 90 degrees. Since there are 4 of them, we would multiply the rectangle by 4, which would give us 360. Similarly, if we were to look at a triangle, you would first divide this into 2, and then we would get 2 right angle triangles. Now a right angle triangle, as it has in the name, is equal to 90. Since there are 2 of them, we would get 180. Now for this is simple. Right? I'm gonna give you a huge but right now. If we were to calculate the area or the angular sum of the pentagon, as they would say, first of all, a pentagon has 5 sides. Now this is what we know about the shape. I'm gonna try and get the best out of what we have right now. It has 5 angles, so angles are equal to 5. And that's all we know, really. We can't find out the sum. That's what you might be thinking. Now I'm gonna give you a huge green but. If we were to use this formula, now the formula I'm about to bring up is the interior angle sum. This thing over here is the same thing as this thing. Now if we look at the n means the number of sides in the shape. Number of sides. We would have 5 sides in the shape. So if we do n minus 2, that would give us the number of triangles. Right? Now and a triangle's sum is 180 degrees. Over here, in this pentagon, we've got 5 sides. That's what we know. So if we were to substitute this equation, 5 minus 2, parentheses, remember that. That's quite important. That would give us with 3 triangles into 180, which would give us a total sum of 540 degrees. Now hold up. You'd be like, hey Dawick, where's the logic? This shape, if we get back to the number of triangles, I'm going to highlight this in a bright red over here. The number of triangles over here are 3. Okay? How? You'd be like, how? So if we break this shape down into 3 triangles, 1, 2. We would draw 2 lines like that, 1, 2, and 3. Remember that this is not to scale. I'm going to clearly note that not scale. ignore my drawing skills. So as you see, we have 3 triangles in the shape. Now, the number of triangles would always be 2 less than the number of sides. So you got proof here, you got proof here. And triangle sum is 180 degrees over here. Voila. Now here's the method backed up by the logic. This is how it works for a complicated shape if you were to find out the angular sum of it. Now you'd be like, hold up, we could do this with a protractor. Yeah, we could. But you see, you would have to measure 5 different angles with a protractor and add it up, which would be crazy hard and challenging for you to do. On the other hand, I suggest that if the question is find the sum of each side. Now, if I were to rephrase this, or to find the value of each side, I could just do this divided by 5. That will give me 180 for each side. Now, each angle is equal to 180 degrees. 108 degrees, sorry. That will give me 108. Apologize for the mistake. Now, voila. This is how it works. But if I were to tell you that this could work for 3D shapes too, that's interesting, right? So in 3D shapes, first what I'm gonna do in a couple of seconds is take a square over here and say we're doing this for a cube, right? If we're doing this for cube, okay, let me just go cube, right? Now hold up, let me take another square over here. First we're gonna you gotta calculate the angular sum of one shape. Now we gotta remember the formula, parentheses, don't forget that, 180. Now here we can clearly see that we have 2 triangles, 1 and 2. So there are 4 sides. So 4 minus 2 into 180, parentheses, 2 into 180. Again, we got 360 for each face. Right? Now, if we were to multiply 360 into 6, we would get 0, 36, 3 goes up, 18, and then we got 21. This is the sum. 2160 degrees. This works quite differently from a typical protractor, and shapes don't work like real protractors, right? So this is the sum of a cube. Let me just quickly write this here. 2160 degrees for a cube. Impressive, ain't it? Now, I'm gonna tell you one more rule. which would explain most of the things that I've taught today. Now over here, if we take something round, like a circle, and now we don't see any sides. No, that's not gonna work out, isn't it? That's not gonna work out. That's not gonna work out. No, we don't see any sides. Oh God, what do we do? Because the area or the circumference is equal to pi. This interesting number is 3.1428 and so on. We don't have anything pointy. We can't use this. That's a big no, cause we don't have any pointy sides. One of the properties of a circle is that a circle can't have sides as it is fully round. Now note that this also applies for shapes like cylinders. Big no. Big no. And big no. Big no. This does not work out. The only thing that works out is you being angry and frustrated over here. So, please remember this rule. It's quite important to remember this rule while finding out the sum of shapes.